Jay, madam, you can start, madam.
Okay, sir. Sir, am I audible, sir?
Yes, yes, yes.
Madam.
Good evening, all. Welcome out to all the participants for 6-day FDP on V2X, Beyond 5G, Trends, Technologies, and Future Directions. Today's topic is real-time V2X, use cases and technologies, decision making, object detection, anomaly detection, and wireless communication in mobility by Mr. Vijay Veera, sir. It is my privilege to welcome today's speaker, Mr. Vijay Veera, founder and tech director, Microsys Logic Technologies, and he is the founder of Microsys Logic Technologies, brings over 28 years of expertise in end-to-end industrial product development with specialized in embedded AI technologies, having strong exposure in SoCs and microcontrollers with RTOS, Linux for embedded products, worked exposure with Qualcomm, Broadcom, Xilinx, Texas Instruments, and Nokia in end product developments, developed multiple patent solutions on industrial IoT and AI camera, executed team across global for customer solutions, provided sessions to 5,000 plus college students on embedded technologies. And he is expertise in semiconductors, automotive, wireless, IoT, AI security solutions. Welcome you, sir. Now I
Yeah.
hand over the session to the sir. Thank you, sir.
Oh, thank you very much. Thanks very much for inviting me to this meeting. Definitely, I would say that this meeting is going to be more technology-based data for you. Oh, so this is how we will move forward. So let's go to the next slide. 1 minute. So let me give you a short brief about myself. I am the founder of the company called Microsys Logic Technologies. I'm with around 28 years of experience in the various technologies, which include semiconductors. I worked on to the post silicon validations. I worked on the device drivers. I worked on device drivers for camera, audio, video, Ethernet, and the various kind of sensors, automotives, wireless. I was heading the group or itself, like that. I worked into various technologies as Jaya was referred. Worked in a Qualcomm, Broadcom, Xilinx, all that. Yeah, a lot of people are aware up to the microcontrollers, but I worked quite a lot onto the SoC, system on chips. Okay, we also talk a little bit on to SoCs in the coming use cases as well. Um, that's a whole thing. Anytime you can reach to LinkedIn. My LinkedIn Vijay Veera, you can search with Microsys Logic, or you can also reach to this call, so contact of my business. His name is Avinash. You can always reach to him. Okay, so today's agenda is going to be, we'll talk a little bit more about what kind of technologies we work on the Microsys Logic technologies, and followed with V2X use cases. Straight away, we'll go to the use cases of the different use cases. We'll take it in the real time use cases and see that how exactly the work involves with the hardware and the software also on the different use cases, and also we'll go into the more onto the technologies, guys. Yeah, so I know that you're also come up with a lot of technology expertise from various colleges. I would like you can hold your all your questions till the end of the session, and we can continue the all your queries. Okay. In case if I'm going fast or anything, you can always inform me to go slower. But otherwise, because I have the slides for around 25 slides, I'll go in the way I'm speaking now. I hope this should be fine for all of you. This is overall my organization, Microsys Logic, with around 15 members team, and our organization works into four verticals. One is embedded software work, and artificial intelligence. We have a dedicated expert and the director for the artificial intelligence based product, and IoT and security solutions. We have in products, and similarly automotive and wireless, and especially we extended towards the renewable energy. Renewable energy, we are building a one product which is a quite innovative within patent idea. We are doing it. So even in the embedded, we are working. So we are working on the products where the intelligence of the AI and embedded is mixed. That's how we are working. It's a mix of both. So we build in hardware, we build a software, and end to end, whatever the customer asks. So we understand the pain point and we come up with the entire solution end to end, which includes the and application, all that. This is the whole thing about my organization. So let me go to the other. So this is the vision what we have. Only thing is our vision is to build the products. Okay. And our partners is MediaTek is one of our partners, and the defense companies also we have a partner. And similarly, we have a partner with UTL Technologies, Samar Raja, and various other customers also we have a partner. Uh, so we'll go on to the real-time cases. So so we know that, so last yesterday, I think you already had a session. So V2X, so vehicle to multiple directions is what, right? So V2X, where, so one is vehicle to vehicle communication. See, vehicle to vehicle communication or the vehicle to infrastructure, vehicle to devices, means in either it's vehicles are communicating with the wireless device, all that, vehicles to pedestrians. So like that, there are different kind of technologies are available in the market. These are all be referred as in V2X, right? So that's what we all know. So this slide I just kept it because before we go into the use cases, so that we are all aligned to the some extent. So the purpose of this V2X is makes more of accidental protection. Major requirement why it came the vehicle to X V2X is that because of the this accidental protection was a major crucial came up, because when the vehicle is going at a high speed vehicles and how to safeguard that, or you take into the transport, especially in the transport, majorly into the transport, when the vehicle is when we send a certain temperature control products, so how it is really is a control product, whether it's a temperature is properly controlled or not in that vehicle. So such kind of things are very important in the real industry. Okay. uh, this is one more slide we kept. So accidental safe, it's nothing but vehicle to vehicle with vehicle to infra, which helps for the zero accidental. So we'll see that how it is, how exactly we do it in the upcoming slides. Okay. This is about the V2X. We will not go deeper. Generally, if we take an example of V2X, what are all the major things will be exist? One is the wireless. So you would have heard about the camera sensors, like 360 degrees camera sensors, or the camera sensors at the front or the rear, and also based on the camera sensors. There is a lot of AI algorithms itself is integrated into a camera, into a car, so that it takes the decision there itself rather than you pass this data to the cloud. So we will take this as a one example in the upcoming slides, one of the use case. Okay, we will look into that. Uh, this is the use case one. Guys, is it everybody's fine with the kind of the speed I'm going?
Yes, sir. Vijay, sir.
Yeah. Is that fine, sir?
Yeah, yes, sir. Yes, sir.
Okay,
Yes,
so
sir.
we took a three use cases. Okay, so
Jayalakshmi.
one. Okay, thank you very much. So one use case we take is the vehicle to vehicle communication. One is the security of the vehicle, and the third case we took is in what do you call tracking of the vehicle for the services. All these three cases, how it is going to be taken care. We will go look into that use case, and then we look into hardware and the software as well. All your questions, if wherever you have the questions, so please keep hold it, so that at the end of the session we'll take it, even if it takes late, that's okay. So this is the one case we have built officially for the Indian defense. Okay, we are not added up with any of the software here because we should not share that. But at least the how we have built, that's what we are trying to show here. Okay, so so this is the let's take an example of, so when defense team has approached us, so one requirement they referred is in the real battlefield, in the real battlefield, the vehicles goes as a together, like 15, 20, 25 vehicles goes as a one troop. It becomes a one single troop, it goes for the war. When they go as a group of vehicles, there is going to be an master commander and there is going to be an individual commanders in each vehicle. Okay, just try to understand this. Now in the present scenario, how it is happening is each vehicle commander individual, right? Let's take an example of 15 vehicles and one master commander, overall 16 vehicles. Out of that, when they go to the war, so each vehicle itself is every vehicle goes into the war. There is nothing called back or the somebody's to keep far away. So everybody for the war. So somebody hits for too many bullets, all that. Same time, there is chances of hitting the vehicle itself, so that the vehicle get damaged also sometimes. So now the situation is like these vehicles, individual vehicle commanders will keep communicate with the master commander over a wireless device, or a voice message, or what do you call RF voice, they will keep on referring, like here it is going to be an high temperature in a vehicle because of the blast here, or the bullets are going down, or the diesel is reducing. Like that, there could be lot of things they will keep on update to the this master command. So master has to note all the information, and they take the decision. So right now the it's all is like a manual. Okay, so now the requirement to make everything to be automated. So I was involved into this whole design where we made the whole thing is an automated of this. So it means that the vehicle, every vehicle will have an hardwares, and the hardwares will keep on collect the entire data of the vehicle, which includes the bullets information. Like we kept a lot of hardwares inside, and it collects about the vehicle conditions, temperature inside and outside situation, everything it collects, and it sends the data to the troop commander. And troop commander get to know, like which vehicle is keep on sending. So here vehicle to vehicle they want the high level security. Try to understand this, sir, everyone. So now each vehicle should send the data to the masters, not to the other vehicles. Okay, so this master vehicle also will be very close to this vehicle within the one kilometer distance. Now, this vehicle's data should be pushed to the master commander, and master commander will analyze the data about the what is happening inside the each individual vehicles. So the goal is that which vehicle is need an emergency. See, like if somebody calls over your phone, always it's a difficult, right, to remember. Like vehicle 7 had a major emergency, and again somebody would have called, like ninth vehicle would have called and said like something else. Who remembers all this? So difficult. So now we made the design in such a way that everything is automated with the wireless communication. Okay. I hope this is understandable for you. So the same thing we are talking about here. The proposal, what we gave the design is like a fire data, oil pressures inside, how the pressures inside, fan, any fan breaks, engine oils, critical RPMs is needed, GPS coordinates, where exactly the vehicle is how it is moving forward, where exactly it is located, and there is a multiple fuel tanks. Okay, it's not going to be a one tank the way we have in a car. So like that, there will be huge data. All the data we needs to be analyzed. Okay, so now so look at here. Okay, now here individual vehicle also has something called a different datas. Okay, so look at here the master. So there is a commander for every vehicle, I told you, right? At the top, so these are all the images we took from the Google. So there is nothing what do you call from the defense. Okay, it's a purely from the Google. So now the commander is going to be present in the vehicle here. That's why it's called master commander for the individual vehicles I'm talking. So there is a master device. Now at the front also there will be a lot of data. There is going to be a lot of data here, and there is a lot of data here also. So now the data, whatever it is collected. So there is going to be some one hardware here, one hardware here. Hardware here, it's a slave and it's a master. Okay. Here, whatever the slave device is there, it will collect a lot of data about the front panels or the what you call fuel information and the diesel information. All that will be collected here, and this data should be sent to the master hardware through the wireless, internal wireless. It's not even the wired because inside nobody wants to have any wire at all, because immediately there is a chance of breaking, or wire get easily breaks, cuts, because of so much of hardness inside. So we want everything to be in wireless. So from here hardware slave to the top hardware, it's going to be wireless here. So we send the data from the slave device to the master device, which is in hard in a wireless mechanism. Here it collects all the data from this slave device. Also there is a additional data this master place exists, which is the bullet shots. Whatever the bullet shots happens, it is happens at from here. So all this data whichever collected by the master device, it will be sent to troop commander. We have seen, right, initially it will be sent to troop commander. Hope everybody understands this. Okay. Now we'll so this is this top glance about how each of these. Okay, slave device we talked, right. So one is the this master vehicle, and this is a individual vehicles. So what we have seen right here, come individual vehicles. Individual, let's understand like this: individual vehicles, and this is the master vehicle. Now individual vehicles have a hardwares, and also the troop commander also has an hardwares. Even troop commander also fights for themselves. I mean, it that vehicle itself, troop commander also has to fight. It's not just the coordinates. He also has to fight. So the data, what it comes from the vehicles, individual vehicle, it collects by the master commander, and here it will be displayed. Entire data will be displayed. So just look at the way this is going to work in the real scenario in between the vehicle to vehicle communication now. Now, we discussed, right? So there is a vehicle, there is a hardware at the each individual vehicle, which is called vehicle commanders, and there is a master commander, right? And here there is no cloud at all. For this use case, there is no cloud at all, because nobody wants to there is easy to hack it. So there is no way I would there is no IoT cloud is exist in this. So all the data in a secured manner, the data will be moving so that no hacking is possible. That's how it works. So each vehicle data, as we have seen at the front, we have seen here, right? Each vehicle, there is a slave and master. So here it is a slave part data will go to the master part of this vehicle through the wireless. And from here, this data goes to the master commander. Now, when the data is passed from the one place to the other place, this is the place where your expertise comes into the picture. So the data, when it is sending from here to here, there is a packaging. So we have to create a packaging here. The data has to send in a certain format. The data, 1 minute, please. So this data needs to be passed in a some packet method, like header, footer, and who is sending it. So like that. Similarly, when the data is coming to the master commander, there are around 15 vehicles data. How it knows that which vehicle is sending it? Again, when the data is sending it from here, again we have to create a packet with the which vehicle is sending it. And when the packet data is received, again it has to do the lot of acknowledge. So this is the place where the networking protocol comes into the picture. So this product we built within, complete intelligence we added up within complete networking protocol. So I hope you guys would have understood now. So in the vehicle to vehicle communication, there is a hardwares we use, and so there are various wireless communications existing in the market. One is like what do you call pure wireless 802.11p, which is specifically for an wireless communication. Similarly, there are other wireless communications exist like a Zigbee. There is a LoRa. There are a lot of versions exist. It depends which one you choose and what is the requirement. Based on the requirements, you have to choose which one. Again, you cannot choose something which is going to cost is going to be very very high. I hope you guys understanding this. So cost is also very very important. So simply this is the highest high level technology I'm going to use, and making the product cost is very very high. Then no point, like no customer will buy it. So we have to look to be like what is the distance it needs, and how is the safety it is follows, and what is the decibel antennas, if you keep it, how much distance it can go. So all this calculation you have to take and take the decision on this wireless packet communication, and also the speed, how much speed the data I want to, do I need to transfer the data with the images? Then it's going to be something different. Whether I'm sending the only the raw data or the something census data, then it might not be needed in high quality wireless. Okay, so that's how it is. Now this is the one more slide we kept. Okay, this is where the how the packaging. So guys, everyone, you need to understand that when you are working on this wireless communication, or when you are working the vehicle to vehicle communications, it's very important that every activities you have to make it as a task. It is very very important. You cannot club all activities into a single task and execute it. So you should split your work in such a way that it got splitted across. So look at here what the way we have built it. Now this is at the individual vehicles. This is at the troop commander. Okay, line in between there is a green, right? See, we are not giving you any source code or anything, so there is nothing what do you call of what we deliver to the customers, but it is a very generic. Okay, now look at here. Here we have used real-time OS. Here we have used the Linux OS. So look at the needs. So it is again depends on the what kind of needs, why it is we kept, because here we need very minimal hardware, because when you use a Linux, right, the hardware will be an expensive. It becomes a complex. You cannot put a Linux on the general microcontrollers. So you need a memory management unit. A lot of things exist. So that's why we won't keep a Linux everywhere. So there is a operating system is very much important in a real-time scenarios. So since the why we need the real-time OS, because these individual tasks engines, or these are the software engines which has to work independent of other tasks. Hence, we will use an operating system. So all this we will be placed along with an application on this hardware, and whole thing will be deployed here. Similarly, look at here. Since we want every vehicle should have a display on what is happening on its own vehicle. So there is going to be a display, and there is a lot of GPS tracking, a lot of things, and the packaging analysis, sending the data to the external commanders. Lot of things exist, complexity. Hence, we kept a complex hardware, and there is going to be an OS which we haven't kept the FreeRTOS. Instead, we kept a Linux. And now from here again, it's the same concept. Okay, so now so initially we tried with around 2 decibel, 3 decibel antennas, and which is touched around 100 meters. But the requirement should go to the kilometer or the longer than that. Now then we again did a lot of research, and then we made a lot of changes in the antennas, different antennas, and then we have shown like it touched to the 1 kilometer. Okay. So before going to the next use case, do you have any questions, sir? Anyone? Or you want to hold all your questions and we'll take at the end? How do you want, sir?
At the
Finally,
last, sir,
Sorry?
in the end of the session, they will ask queries, sir.
Okay, excellent. Thank you very much. So that's the case. We have looked into the vehicle to vehicle communication. Now we will look into the okay. By the way, so this kind of a solution, what we discussed now, this solution we can also extend for various use cases. So various, maybe you guys also can think of some use cases and you can propose it and you can approach us anytime, no issues on that. But so this kind of a solution, now I gave you one case, but you can think of your different cases onto the drones because ultimately it's wireless vehicle movement, similar movement, or you can think of in the what you call VIP security. So like that, you can think of some kind of a solutions where you can develop a solution, end solution. You can develop it. Okay. So now use case two, we will take it up. In the use case two, we'll talk about the vehicles tracking in the transport. So the requirement what we have is what we have the vehicle requirement is that so take an example. One transport have around 500 vehicles across India. Now it is very difficult. So to track the individual drivers, it's very difficult to track the individual drivers, how they are behaving inside, whether they have drunk or not, whether they are going at the right places in the right direction or not, or or is it you see a lot of places in the transport, the locking and unlock. So they know they would have locked it, but there are chances of unlocking and take theft the certain items and again they lock it. Such kind of things also there are chances. We have a requirement for like that, where we have seen the customer asking for such kind of an security, so that in during the transport never ever happen that unlock happens to the transport. Similarly, the vehicle temperature, like especially the cold control or cold specific based some materials when it is going, and they want very much like whether it is maintained the right temperature inside the container or not. So such kind of requirements always comes. Okay. So so when there is a somebody 100 what do you call 100 vehicles or 200 vehicles, it's very difficult. So we built a one product. Let's look at once. So this what you are seeing now is more of like an drivers whether is sleeping or not. Look at here, there is a camera also we placed and there is an hardware we placed which will keep on analyze with the AI algorithms on the persons whether is right way or not. So you would have seen that see there are certain vehicles because of the vehicle load, uh, it can go beyond certain speed. It cannot go beyond speed, but the drivers will drive it because they have the access to that. So assume the vehicle has to go at the 60 speed, it goes at the higher than that. So now this solution is going to track each and everything why the person is so because that's how it is. Certain high loaded vehicles has to go at 33 is the speed max or the 40 is the max speed, means they cannot even drive it beyond that. That's how it is. So look at here. So that's the requirement. So now we build a product, and this product is going to check the entire vehicle's movement, where it is vehicle is moving and where exactly is located and how many vehicles are there. And look at here, one vehicle is alert vehicle, means that is something is wrong. So this is we call it a dashboard. This dashboard is going to maintain with the transport team, and where transport team is keep on checks this which are the high alerts. Okay, so it shows that where is the risk. So somebody would have kept the vehicle for a long time in some place, it is not accepted for the transport team because ultimately it has to reach in a 2 days time or 44 hours or some specific time, and it is not reached. So this kind of analysis what we made for the vehicles tracking. So we'll see that how it is happened here. So now here, so in earlier case, we have not used the cloud because we don't want this, that privacy secure data should not go and visible for anyone. But here, this data has to be remotely viewed by the transport team. So now here we keep all vehicles will have the vehicles data. Vehicle has in something called a gateway hardware. There is called and we call it in gateway hardware. This gateway hardware will keep access the lot of things. Take an example. Now, what we have seen that video, right? So here, there, it's a more of a face detection. There is a face detection and a recognition of the driver. So that's also very important. The driver is specific. This is the person only has to drive. If someone else is sitting in the driver's seat, it should intimate alert saying that this is not the right person to sit. Sometimes what happens is we see that the driver, conductor, whoever sits next to him is going to use the car drive. They will drive the vehicle for certain distance. So the driver gets sleep for some time. That's not accepted for them. So such kind of things we developed something called face detection with the cameras, and and now it continuously analyze on the face on the image along with the eye and mouth movements. And eye is majorly is for to see that whether it's a really eyes are getting closed or whether eyes. So these are all the certain movements what standard movements to check across to see that whether the driver is getting sleep or not, and whether the sometimes the person is looking into the side for a longer time, chances of the vehicle going at certain speed, it is a risk. It's a risk, right? So such kind of an analysis, everything should happen within the vehicle instead of at the cloud place. The reason why we don't want to do at the cloud is because so cloud, when I push it, see the what is the goal of this? Our goal is to intimate immediately to the driver something is wrong, like the person is getting a sleepy mode. Immediately it should give the horn to him, or this little bit of what do you call sound system inside, so that he will wake up fast. He will look up once. Okay, so we cannot put this data to the cloud and cloud analyze and give it back to the vehicle to say that the driver is sleeping. It takes quite long time. Correct, right? Again, it depends on the distance. See, what happens is when the vehicle, how much speed you talk about, like when you use an 5G network, even at certain places, in the certain remote places or even the highways, lot of places you will not have such a good network. Then it's going to be trouble. So that's why the decision should happen within the vehicle itself. Now, how that is going to happen? If it has to take the decision there itself within the vehicle, you need to use an high speed processors. You would have heard about something called a microprocessors and microcontrollers. I don't require to explain about that. But microcontrollers are usually it's a single processor based or dual processor, but not so much high speed. So that is not going to be useful in case of an AI analysis based products. Like this is an AI direct analysis should happen here immediately there itself. Now here in this scenario, we use a system on chip. I hope you would have heard about system on chip. And in this system on chip, guys, is it audio is fine for everyone?
Yes, sir.
Okay,
Fine
excellent.
one.
Thank
Yeah.
It's great.
Okay, because I didn't get any acknowledged, so that's why I got doubt. So thank you. So now system on chip is something like where the if you look at the Qualcomm or you look at into the Broadcom or Nvidia, nowadays everybody is coming up with an AI engine based processors itself is coming. Now in those SoCs, it's going to be around more than one, two, three, four processors. There are max of eight or even the 10 processors are integrated into single SoC. So minimal to minimum, I can say that the SoCs contains around four processor integrated into a single chip like a microcontroller, along with various other peripherals. And in that context, each processor can run at a minimum of 1.5 gigahertz to 2 gigahertz. So now in that case, one processor can process the camera data, and other processor can do the AI engine analysis on the face detection and further analysis and the taking the decision, something like that. So it's going to be very very fast, because see, as if, right, like when I'm driving a vehicle, I should get intimate if I'm sleeping or something deviated. I should get intimated within a milliseconds, at least by milliseconds. It shouldn't happen that, after the 2 seconds it got intimated. That's too bad. It would have been already accident. I would have happened. So when we use in such kind of an SOCs, the decision making on the person's drive will happen in the microseconds to milliseconds time, and generates the noise so that, driver gets an drivers get an alert himself. Okay, now same data. So that's how we do that. The SoC based product hardwares, we place it here inside this car, and then the data, regular data of the vehicle, like a fuel conditions or the vehicle when it has to go for the maintenance, inside the temperature, how is maintaining it, all the information, including certain alert level images, can be pushed to the cloud anytime. It will go to the cloud, and from the cloud, the data can be retrieved by the web application on the end, in the end, where the transport team can visualize the vehicle. So as we discussed here, the whole thing can be visualized. So here, this is what is hardwares we talk. So there is going to be a lot of sensors. We'll keep it. A lot of sensors we'll be using it. So when you want to read all this data, and similarly, software side, if we look at the overall in the software side, one is the gateway. We call it generally the gateway. The gateway, it gets the data from the various sensors for the analysis here. Also the AI engine part, as I told you here, AI engine also does here. And wherever the alerts are intimating, same data has to be pushed. So all the data will be pushing to the cloud. So here the cloud is going to be either it is AWS or it could be GCP, or there are a lot of clouds are exist in the market. So we use any of the available clouds where you can push the data in the form of database in the time model, where there is going to be a time at what time we are pushing the data is very very important, right? So ultimately that is very very important. So that time is also important. We'll push the data along with the time to the database, so that the from the end application, anytime they can retrieve along with the time to know that at what time these incidents are happened. So that's how they can look at. Similarly, in the IoT, definitely we use an MQTT protocols. We use it, and the database data analysis if needed any further. And the data solution dashboard is the place where we use the React is the beautiful one case, or the Qts people uses, or any Java based applications we keep, and raise the queries to the cloud the way what exactly the data you wanted. Okay, I hope this is clear for you. So the other third use case we took is about the servicing. So take an example. Take an example. We go a little bit deeper into the individual vehicles now. Um, Take an example. There is a showroom. There is a car servicing showroom. Right now, you would have seen that EV vehicles, a lot of EV vehicles exist now. And these EV vehicles, everything runs with, entirely an electronic. Entirely it's an electronic, right? EV vehicles are entirely in electronic, and a lot of issues still, a lot of getting they are getting it. So now they want to evaluate. Take an example. Any of the manufacturer, they want to see how it is performing in the market, whether these vehicles, because see, once they got, once the customers feel like something bad about these vehicles service, or whether the vehicles are not performing well, completely they should shut down their product, right? There is no use. So they need a continuous analysis of these EV vehicles, or even any other servicing vehicles. Okay, now, so this is what is again, it uses vehicles to customers, individual customers communication analysis. We call it a supervisory control SCADA solution, data acquisition solution. So here the completely the individual vehicles. So individual vehicles data will be completely tracked. Completely tracked. How we track it? So we will place a gateway. The way we talked about the gateway, right, in the previous device. Similarly, we keep in some hardware where there is a definitely need of a GPRS. Definitely, it is needed a GPRS here, and GPS also needed. And this hardware is going to read the data of the various parts of the vehicle. Take an example in the EV vehicles, especially the battery system is very important. Where which state it is, whether it is, see, they would have charged it. When they charged it, the battery, and whether the battery charge time, they would have said, like, if you go at the 40 kilometer speed, it would have reached a 5 hours time. But in the reality, if it is coming at only three and a half, sorry for that. So when the battery is full, they would have said like 300 kilometers will be reaching if the person drives at 40 kilometers. Assume the person is really driving at the 40 kilometers, but it's not coming at that, and there is a 20% lower than the what is expected the kilometers. That even if the customer goes back and tells to the servicing team, they won't accept it. Correct, right? They won't accept, we given it. But that's not accepted, because if not accepting by the these vehicle companies, there is a finally it's a bad feedback in the reviews. So now they don't want to involve into these are all situations and take an early analysis on the each vehicles. Now what happens is EV vehicles or even the braking system, whatever it is, it will keep on checks internally how it is working, because everywhere there is a sensors. These sensors will keep on send the data based on the gateway requests in the inside the vehicle I'm talking about. And once it collects all the data, one is going to show it in the dashboard on the same vehicle. Same time, the critical data, whatever the important data it needed, the data will be pushed to the actual car organization, wherever, or the car servicing center, wherever it, whichever is the company. So it will send and they will analyze based on the what speed the person went and what has happened, all that will be analyzed. So this is one product where if you look at, right, as I told you in the previous case, here also you required the lot of complexity of your hardware. So the bottom layer is entirely an hardware, guys. So here you look at here, there is an application processor we call. So, and there is a modem processor. So this is called a modem processor because there is a GPRS, we'll put a SIM stick, right? All this is a modem. So now here this LTE, it's a 4G or 5G network based. So usually what happens is there is a complex chipsets exist, which is a SoCs, where there is a application processor and there is a modem processors also exist inside. So this LTE part is integrated into that in the modem processor set, so that it takes care of that. And application processor is where it takes care of communicating with all the hardwares. And if needed, there is a application dashboard also will be placed in the same vehicle. So there is a operating system is very crucial here. So here in such kind of a complex cases, We won't use a ATOS. We use in complex, what do you call the QNX might be, because vehicles usually, a lot of vehicles, most of the vehicles in the market uses the operating system is QNX. So similarly, some companies uses the Android based Linux within Android. It depends on their needs. They will use that. So that's how it is the whole vehicle data. And this kernel is nothing but this is the lowest software in an operating system where the lot of drivers exist, serial drivers and the various other modem drivers, lot of other drivers which will actually communicate with the interfaces. And this kernel and application entire software is going to run it on the application processor. Hope you understand, right? So OS is always runs on the processor. That's how it runs. So more detailed about the ADAS telematics is this is very important. So ADAS system is nothing but advanced driver assistance system, which existing inside every vehicle in a cars, where there is a sub blocks like a sensing components, positioning components, and also the processing other processing units exist inside. So sensing side, definitely the crucial comes is cameras. We use rear cameras, front cameras, surrounding cameras, different kind of cameras we use for the face recognition of the driver. Not only that, even we can extend these cameras with a lot of other safeties inside a car, like a theft system. Also, we can consider these cameras for the theft system. When you logged it and somebody is trying to access it, if the person is not the same person is driving, so it immediately intimates in a message saying that someone else has unlocked your car. So it's all the intelligence, how you write these algorithms. That's important, guys. So similarly, radar sensors. So this is very important when the vehicle wants to communicate with the next vehicles or the surrounding vehicles. So this is majorly used for the collision impacts. This along with the lidar sensors we use together. We use for the detection process for the collision avoid all that. Similarly, GPS systems we use it, GPS systems, um, and other control units. Especially if you look at into the cars or the vehicles, there is a lot of electronic components exist. We call it the ECUs. So individual ECUs will have its own processors. It takes the decision of its own. Something like engine analysis. There is going to one ECU, and the cameras related on the some dashboard related, there is going to be multiple ECUs exist. So all these ECUs data is going to be collected by one master control unit. It collects and it published to the cloud or to the dashboard. That's how it is. So guys, most of the places, so it is a decision by the manufacturer whether should I to use an SoC or whether should I to use a microcontroller. It again depends on the decision making of the based on the ECU size or the ECU subcategory of the sensors, what it uses. Based on that, it takes the decision. The manufacturer takes the decision whether should I to go to use an SoC or the control, because SoC is always an expensive. One is an expensive. Second is a power consumption is also a little bit higher in case of a SoCs. But important point is that in the controllers, it runs at the megahertz speed. Usually it's going to be megahertz, less than 150 megahertz, 200 megahertz, not more than that. BC. So roughly like that, never be in the gigahertz. SOCs are the real use cases where multimedia or the camera, video or the AI part exists. Usually we go with an SOCs where a lot of analysis is needed, and there is a dashboard or the you would have seen, right, in the cars, every car is having a front display, beautiful display, where your it shows the GPS mapping. It shows the camera of the back and the rear and the front, and also internal temperatures, everything it will be shown in a one dashboard. Means there is a lot of complexity should be taken care in the dashboard solution, which needs an SOCs. And on top of that, they use an Android. When they use an Android, it is a very process involved. A lot of process time is also existing in the Android. Lot of cases where SOCs is the best choice for them. So it will not run it on the controllers. Okay, so that's why it's a selection of the microcontroller, the SOC. It's decided by the manufacturers based on the kind of processing is done by this ECUs. Okay. Software components generally we call it's an operating system is a very much important in the crucial role in all these topics. Operating system optimization of the operating system and the modules enabling inside that, drivers enabling sometimes whatever the drivers exist. Drivers means device drivers I'm talking about. The software part, device driver is nothing but these software which communicate with the hardware. So sometimes what happens is you default the Linux. Take an example. Linux would have given for the one of the camera sensors, but because of custom, say take an example, Hyundai, they would have said like, they don't want to use that specific camera sensor. They want to use an Sony Ericsson's. Now there is a change in the drivers. There is a lot of optimization also might be required inside the multimedia blocks inside the operating system. So these are all has to be done. Similarly, look at so these are all the top level we kept, but there is a lot of sub blocks will be there. That's from the whole thing. How to get into these technologies, one slide I kept. So definitely anybody, your team wants to get deeper into these technologies. I want this following slide is going to be quite useful for you, all of you. Take an example, embedded systems is very important. People should know about the embedded technologies. Like I know that you guys, a lot of people have your knowledge onto the processors and controllers, and also SOCs. So guys, my point is that so you might not require to work on the assembly programming. This is what I want to tell you that. So usually we the assembly programming until we write a low level software for that. Okay, so because already they would have whoever is the seller of this processors and hardware boards we purchase, usually they will write a small tiny firmware which hasn't firmware boot up sequence exists in that. So you don't require to worry about the assembly programming at all. Most of the time, until you are basically you want to write completely your own, you want to write it from the bootstrap, then you need an assembly. Otherwise, usually you will not need of that. Mostly it's a C++ programming we use. Similarly, ARM is very much is important because 90% of the world market is dominated by ARM. So definitely people should know about the ARM. And importantly, SOC is very crucial to know. Apart from the microcontrollers, and definitely I would say the communication interfaces everyone should know. Majorly in the case of camera, in case of vehicles, we use a something called a CAM protocol we use. Apart from along with I2C we use UART. These are all other protocols we use. But other than that, even CAN is a majorly used. Similarly, real time one operating system everyone should know it, and wireless communication. People should know about the wireless communication like Zigbee or LoRa at least one some level. You don't require to know about what is that Bluetooth firmware or the Wi-Fi firmware. Usually you don't require it. But what is very important is how you write the packaging protocol is very important, because that is the place where you show your uniqueness, right? So because every product has its own packet size, every protocol, all that, so when it is vehicles are moving, so individual vehicles, vehicle to vehicle, some data to be pushed, so there is need of some protocol of the size of the packet, how much is each, uh, what size we send it, all that is very important. That is the somewhere that's more of a software side of the networking protocol. It's a very important for everyone. Apart from that, IoT with the cloud, and yeah, definitely it's a dashboard if somebody develops in any GUI. This is very important. So thank you very much, guys. Anytime you can reach out to our business manager. His name is Avinash, for anything technology side to work together on any common products if you have it. So we can definitely work. With that, I'm done from my side. If you have any questions or something, please, you can raise your question.
Thank you, sir.
Thank you very much. Yeah.
Participants, you can.
Parts. Yes.
Yeah.
Any queries from the participants?
You put it in the chat box also.
Okay, sir.
Any queries, you put in the chat box also.
Hello, sir. Am I audible, sir?
Yes, yes, yes.
Sir, what kind of routing protocols we will use in V2V and V2N or other kind of
Uh, okay. What kind of protocols we use it, right?
for routing, sir, especially
When you're routing means till where you're talking about? Routing to where?
vehicle to vehicle, sir. Mean if I'm
Mm,
if I'm both the vehicles are in same antenna or if the vehicles
mm,
fall in vicinity,
mm.
what kind of protocol do we use? It is Wi-Fi or how, sir? In between.
Okay. So, thank you very much. So the question is, when the vehicle to vehicle, when it is communicating, when we use an antennas, absolutely there is a need of an antennas here. When they use an antennas, so what kind of a networking protocol they use, like whether it's a purely and wireless or anything else. So first of all, I would like to tell you about the antennas first. So it's very important that what is whatever the protocol it follows in one side, other side also has to use the same. Take an example, the antennas are with the 2.4 gigahertz, assume the other side also we have to use the same 2.4 gigahertz. Okay, so or something else standard we have to use another side also same. That's one thing. So antennas should be aligned with the same frequencies, and decibels, it's up to them. So if the decibels are good, so it will reach to the long distance. But coming on to the wireless side, one is especially to the vehicle to vehicle communication. There is a standard wireless protocol is developed. We cannot use a regular general 802.11 protocols or 802.11n. All these protocols we cannot use it because these 802.11 regular standard what we use in a home, right? At home, whatever the we use the wireless, it works in the concept of acknowledge based. So it won't allow everybody to access to the network until authentication is done. Until that, no one can join to the network. So that's why we can't use the regular 802.11n or any other usually. So instead there is something called 802.11p, where it's absolutely it's only developed for in vehicle to vehicle communications, and where there is no authentication from the both sides. There is nothing. So once somebody is near to the network, they can join to that network. You got it right. So that's one way of the wireless communication. Similarly, the other alt, but again it depends. Like 802.11 means again you have to use an high-end processors because its cost also very high. 802.11n, 802.11p vehicle specific standard devices is very expensive. So instead of that, you can go for a Zigbee, or you can use an LoRa if there is not much data. So assume like in, see, usually what is important, we have to understand that when the vehicles are communicating, it's more of the real data, right? You are transmitting of the data of where my vehicle is present, what speed I'm going. These are very important. So it doesn't require so much of complexity of the images or anything. So then you don't need of in 802.11p for across everywhere. Instead you can use something like LoRa is the one of the beautiful way. It works at the 115k speed, and data goes with a very simple 1K bytes of data you can send. Similarly, Zigbee, you can use it. So like that, there are various wireless standards.
Yes, sir. Yes, sir. Got it, sir. Thank you so much, sir. Yes, sir.
So, what communication modules are the sensors are best? So, there's others are also there in the chart they kept. So what kind of your communication modules are the sensors are best suited for to implement V2X with Raspberry Pi and is suitable for V2X? So actually we have used the Raspberry Pi for the initial demos for the V2X. Absolutely fine. So again, I'm telling you, when you say V2X, is it the data related where my position exists, what speed I am going, and this kind of data, if you want to send it to the cloud or to the nearby data like GPS data, all that, absolutely Raspberry Pi is good enough with a LoRa or the Zigbee, anything is good enough with a GPRS. GPRS is very important because if you want to use a cloud. NVIDIA. So similarly, is NVIDIA Jetson suitable for V2X? So NVIDIA has a one beautiful advantage when compared to Raspberry Pi is that the processing time is very less in case of NVIDIA because the goal of NVIDIA Jetson has developed is for AI processing purpose. Absolutely, it has developed for AI images. Okay, so NVIDIA is much faster. We call it's much faster when compared to Raspberry Pi 4. But now, if you look at into the Raspberry Pi 5, again there is they have integrated AI engine integrated into the SoC itself. So Raspberry Pi 5 also you can try, but NVIDIA Jetson is a little bit much better than the Raspberry Pi 5. But the cost also you have to look at. So NVIDIA Jetson is cost around, if my understanding correct, around 30 to 50,000, something around, which are so that's from the. There is a one more question, which are compatible with ESP32. So now, okay. Mm, there is a question from Poonam about which are all compatible with ESP32. ESP32, right? So ESP30, the advantage of ESP32 when compared to Raspberry Pi or Jetson is that ESP32 is having a lot of ADC pins exist, lot of GPIO pins exist. If you have any simple products, so it's better to use an ESP32 rather than Raspberry Pi. It again depends on the what exactly use. But coming to the V2 vehicles communication with ESP32, so still you can use with Zigbee. You can use a Zigbee with ESP32. Definitely you can use it, but the speed is important. Speed is lower because ESP32 usually it is at around 100 megahertz around, whereas NVIDIA Jetson it is at around 1.5 gigahertz or higher. Raspberry Pi is also touches to around 1.2 gigahertz. So it again depends on what rate you want to send and what time you want to send. Do you want to send? Assume like I want to send the large data in a seconds, in a every second. Then ESP32 might not be the right case for you. Okay. So otherwise you can use the ESP32 also if you have a lower data sending. Any other queries?
Audience, any other queries?
Sir, you mentioned it as you'll be splitting the task into various subtasks.
Okay. Mm-hmm.
How do we integrate it, sir? Integration part, how do you do it? Sir?
Could you repeat? There is a flicker in your voice. So go.
Sir, actually, we have many subtasks, right?
Correct.
We cannot implement as a whole, right?
Hmm.
So, how to integrate these subtasks?
Hmm.
And what is the module you use in order to integrate?
So, so I hope everybody got the question. So the question is when there is a multiple tasks exist. because this vehicle communications, all that is much complex, where there is a lot of individual tasks has to done independently. Then how these tasks are managed. So this is the reason why you have to use an operating system. So when you use an operating system, in the operating system, you can create, take an example, madam. Take an example. My requirement is I want to read temperature of a vehicle on every 10 seconds. Okay. I want to take the data of temperature on every 5 seconds. This is one requirement. Similarly, the other requirement is that I want to process the camera data of the image on every 10 milliseconds. Look at, there is a change in the requirements. Now I have, so to run both parallelly, right? Both should run in a processor. So ultimately it has to run it on your same processor. So how it works is the operating system provides the something concept called a threads or the tasks. We call it the threads. Sometimes some people call tasks. So I will make this every this temperature read on every 10 seconds. I will make as one task, means or a one thread in a operating system. Similarly, I will create a one more thread which is going to be on the milliseconds of the camera data reading and do the process. So when I make it as a threads concepts existing in the operating system where it will independently runs independently, because your processor runs at very, very high speed. So ultimately processor runs only one task, either this task, so one of the instruction in this task or instruction in the other task. Ultimately it's only instructions. But since my processor, when it is running at the gigahertz, you never know that whether it's running, you feel of it's running parallel. So that's how it's a task. So take an example, your phone itself. When your phone, you have your WhatsApp calls, same time you have your call handling, right? When somebody calls, you get the call. Same time you are listening to the YouTube and there is a video in the WhatsApp. So many things, complex things and parallel. How these are all managed. So these are all independent modules which are running as independent tasks or threads in an operating system. Any other questions?
Okay, thank you, sir. One more question, what is the GPU? Suppose if I go with SOC, so what must be my GPU rating, sir? Can you please tell me about this?
So GPU, it again depends. Okay. So GPU, see, some modules, if you take a Raspberry Pi 4 and all, it doesn't have a GPU, but Raspberry Pi or NVIDIA, if you take it, it will have some GPU part. Yeah, so ARM is not used for the GPU purposes. It has its own instructions. So it has its own instruction set compared to ARM instruction set. Hope you know that both. So ARM is majorly used for application processing side. GPU on the AI engines are used specifically for AI processing or the graphics part of that. So you can exact numbers I will not have it, but GPU should be at a good speed as an ARM speed.
Okay, sir. As you said, you have implemented it in a military project, right? So
Hmm.
definitely you would have used the
No.
GPU. So
Huh.
approximate rating, if you say as so that it would be
So
useful
it
for us.
again depends, like, see, your requirement is like, take an example. Now my processing is like 30 frames per second. I have to process at 30 frames per second. Now think of push your, see, capturing of the data, camera data of 30 frames per second is like through camera, means through the ARM processor or application processor, we do that. Now this data should be processed by the GPU engines in within AI algorithms to run it there, right? That is a very, very important. AI algorithms to run it on the AI engines. So that's a where how much time it takes. So you have to look into the which processor you are using and which SOCs you are using. That then only you will come to know. Otherwise, you will not be knowing it. So when you get the process SOC, right, they also give these numbers, GPU numbers, all that. Based on that, you can get it. Okay. Yeah, go ahead. Any others? Any others have any questions?
Audience, any queries?
I would request everybody to give the feedback on
Yeah.
this session.
Thank you, sir.
I hope this information is value for you, because I try to cover the hardware and software as well, apart from this vehicles wireless communications. Okay, guys. Thank you very much for
There,
everyone.
madam, you conclude, madam.
Yes, sir.
Thank
Thank
you.
you, sir. Thank you for
Thank you.
sharing the information on the test cases on wireless secure data communication between master vehicle and other vehicles, and
Yeah.
also vehicle tracking and SCADA for vehicle analysis and services.
Right.
And what are the hardware or software analysis which we need to do for all these test cases.
Right.
Thank you, sir, for the information, sir.
Thank you. Thank you, everyone.
So
Thanks.
you can
Bye.
stop sharing, sir. Stop sharing. Or you end the session.
Vadivel,
Ah,
if you share automatically, sir will come out.
okay, okay.
You share next.
Yes, yes,
uh,
yes, yes.
speaker automatically.
Sorry
Okay.
for that.
Okay, okay, sir.
Thank you
No
very much,
problem, sir.
guys.
Ah, thank you, sir.
Thank you, sir.
Thanks. Bye.
Bye, sir.
Vijay sir.